Okay, today we're going to be looking at compound interest, and you can see here I have my formula and what each of those variables represent. I also have the n values listed for how many compoundings there are per year, whether it's annually, that means it happens once a year, semi-annually, twice a year, and so on. One thing I want to point out about daily is that no matter how many years we're going to go out with our compound interest, 10 years, 20 years, we're always going to assume that there's 365 days in a year where it's going to ignore leap years. All right, problem number one. How much money will there be in an account at the end of 5 years if $1,000 is deposited at 6% interest compounded quarterly? Right, when it's asking us how much money, that is my A that I'm trying to figure out. The end of 5 years, 5 is going to be T. I'm depositing $1,000, so that is the P. 6% is my interest rate, so that's the R. When it's compounded quarterly, that means N is going to equal 4. So I like to start off these problems by writing down my formula. And depending on the calculator you have, you may need to put that exponent n times t in parentheses. But now we're going to just plug in all of our values. I don't know what A is. That's what I'm trying to find. P is 1,000. R is 6%, so as a decimal, that's 0.06. N is 4. And I'm going to raise that to the 4 times 5 power. So put that into my calculator, and I end up with $1,346.86. Okay, problem 2. How much money needs to be deposited in an account that earns 4% interest compounded monthly if you wish to have $8,000 in 5 years? The amount of money that needs to be deposited is what I'm trying to find, and that is the P, the principal. The 4% is the R. It's compounded monthly, so N is 12. The $8,000 is the amount that I'm going to have in the account at the end of 5 years. So that 8,000 is A and 5 is T. So again, I'm going to start off by writing out my formula. A equals P times 1 plus R over N to the N times T power. A is 8,000. P is what I'm looking to find. N is 12, and that's going to be to the 12 times 5 power. And I'm going to go ahead and multiply that exponent. Now, if this fraction here is going to divide out to a terminating decimal, like say it's 0.0125 and then it stops, you can go ahead and put that into your calculator and get that answer. But this one is not a terminating decimal, so I'm just going to leave this as 0.04 divided by 12, and that's going to be to the 60th power. Now this whole thing here that's in parentheses and the exponent of 50, this is just a number that's being multiplied by P. Right? Just like if I had 100 equals 5 times x, and I want to get that variable by itself, I need to divide by that constant. I would divide both sides by 5. Well, over here, I'm going to divide both sides of my equation by that number. So P is going to be 8,000 divided by 1 plus 0.04 divided by 12 to the 60th power. And you can put that into your calculator, and you're going to get approximately $6,552.02. Okay, problem 3. Suppose $4,000 is deposited into an account that draws 5% interest and is compounded quarterly. How long will it take for the account to reach $8,000? Okay, $4,000 is the amount that's deposited. That's the P. 5% is the R. It's compounded quarterly. So N is 4. How long is the T? And that's what I'm looking for. Will it take for the account to reach 8,000? And that 8,000 is my A. So I plug all of that information in. I already have my formula written down here. 8,000 equals 4,000 times 1 plus 0.05 divided by 4 to the 4t power. Now, I'm going to, first of all, simplify what is inside those parentheses. .0125. Now I stop and look at what I have here. I've got my variable in the exponent, so now I'm going to be using logarithms to get that variable out of the exponent. But the first thing I can do, though, is get rid of that 4,000. So I'm going to divide both sides of my equation by 4,000. So I have 2 equals 1.0125 to the 4t power. Now, from here, you can do this a couple of different ways. Your book is going to tell you to take the log of both sides. And solve the problem that way. But remember that if you just have an exponential equation, you can write this as a logarithm. So I have log, the base is 1.0125, and this is 2, and that's going to equal 4t. Remember that the exponent goes over here on this side. And now I can divide both sides of my equation by 4. The 4's are going to cancel. So t equals the log of base of 1.0125 divided by 4. And you can put that into your calculator, and that's going to give you approximately 13.9 years. Now, the traditional way to do this problem is to take the log of both sides. So I would have the log of 2 equals the log of 1.0125 to the 4t power. Then I would move that 4t up in front of this logarithm. So I have 4t times the log of 1.0125. Then I can divide both sides of the equation by 4 log of 1.0125. And remember that when I don't have a base written with the logs, those are common logs, right? So that 4 will cancel, the logs will cancel, so t equals the log of 2 divided by 4 times the log of 1.0125. And you can put that in parentheses, and it will make your computation a little bit easier, so you don't have to do 2 different steps there in your calculator. Okay, problem 4. Suppose $5,000 is deposited into an account that draws 3% interest and is compounded quarterly. How long will it take for the account to reach $9,000? So you can see I've already got our formula written down and I've already filled in the numbers here. I'm going to start off by simplifying what is inside those parentheses. Now, you're not always going to be able to do that, but in this case I am. I'm going to be able to have 1.0075 in there, and that makes things a little bit easier. Now, when I am dividing here to get rid of this 5,000, I'm not going to have this to divide evenly over here on the left-hand side. So there's a couple of different things that you could do. You could just write this as a fraction of 9/5, or you could write it as a decimal if you have a terminating decimal. Right? So I'm going to go ahead and write this as a terminating decimal of 1.8. It's supposed to be a 4. And from here, I will let you try to solve it on your own. So pause and then pause the video and then come back and check to see if you got the right answer. Okay, there is your answer. And with these next set of problems, we're going to be looking at interest that's compounded continuously. So instead of like quarterly, like 4 times a year, monthly 12 times a year, it's compounded continuously. And my formula for that is A equals P e to the RT power. So problem number 5. How much money will there be in the account at the end of 5 years if $1,000 is deposited at 6% interest compounded continuously? How much money is going to be at the account at the end of 5 years? That is what I'm asked to find. That is going to be the A. 5 years. 5 is the T. $1,000 is deposited, so that is P. And 6% is R. So A equals P e to the RT power. So A equals 1,000 e to the 0.06 times 5 power. So oops, it's $1,000 instead of $100. So you just put that into your calculator and you're going to get for your answer $1,349.86. Problem 6, how much money needs to be deposited into an account that earns 5% interest compounded continuously if you wish to have $7,000 in 3 years? How much money needs to be deposited is the principal. That's what I'm looking for. R is 5%. 7,000 is how much I want to have at the end of that time. So that's my accumulated interest. That's A. And T is 3. So my formula here, A equals P e to the RT power. A is 7,000. P is what I'm looking for. R is 5%. And T is 3. So this is 7,000 equals P e to the 0.15th power. So this is just a number, a constant. Just treat it like you would any other constant. Divide both sides of the equation by that in order to get P by itself. So P is going to equal 7,000 divided by e to the 0.15 power. And that is going to give you approximately $6,024.96. Okay, problem 7. How long will it take $3,000 to grow to $5,000 at 3% interest compounded continuously? So I have my formula written down. I've plugged in all my numbers already, so now I'm just needing to solve this. First thing I'm going to do is to divide both sides of my equation by 3,000. Over here on the left-hand side, this is not going to divide evenly, so I'm just going to leave that as 5/3. And from here, there's a couple of different things that you can do. I'm going to take the natural log of both sides of the equation. Natural log of 5/3 equals the natural log of e to the 0.03t power. And I'm going to be able to simplify the right-hand side here, and I'm just going to end up with this exponent. Remember this saying, what power do I need to raise e to get e to the 0.03t power? Well, 0.03t is what I need to raise it to. And now I can divide both sides of my equation by that coefficient. And that will cancel. So t equals the natural log of 5/3 divided by 0.03. And that's going to be approximately 17 years.